We spent decades searching for clean energy above ground, from wind, the sun, rivers, and tides. But what if part of the answer has been beneath our feet all along? I'm not talking about fossil fuels, but something different entirely. Clean energy produced naturally in the Earth's crust through geological processes and with no emissions. Scientists call this natural or geological hydrogen. Others call it white hydrogen. And while the oil, gas, and mining industries have known about it for decades, the clean energy world is only now waking up to its potential. So, could natural hydrogen be the buried treasure of the energy transition? Or maybe it's a fool's gold rush? Today, we're going to try to answer that question. We'll also be discussing whether Canada can become a leader in understanding natural hydrogen, finding it, and extracting it at the scale and cost needed for it to become a meaningful part of our low carbon energy future. I'm Derek Estabrook, Executive Director of the Atlantic Hydrogen Alliance and the host of Atlantic Canada's Hydrogen Future, a podcast about the industry leaders, energy experts, innovators, researchers, and policymakers writing the next chapter of our region's hydrogen story. My guests on the pod today are two of Canada's leading scientists working at the frontier of natural hydrogen research. Dr. Barbara Sherwood Lollar is an earth sciences professor at the University of Toronto. Her pioneering research helped establish the scientific foundation for understanding how hydrogen forms naturally beneath the Earth's surface. She was appointed as a Companion of the Order of Canada in 2016 for her groundbreaking contributions to geochemistry. And Barbara was recently the co-author on a landmark natural hydrogen policy briefing examining opportunities and limitations of natural hydrogen extraction. Omid Ardakani is a research scientist with the Geological Survey of Canada and Natural Resources Canada, and also an adjunct professor in the Department of Earth, Energy, and Environment at the University of Calgary. He's a leading voice on natural hydrogen exploration and is helping to lead efforts to map and identify the regions of Canada most likely to hold significant natural hydrogen deposits. Barbara and Omid, welcome to the show. Let's dive right into this fascinating topic. Barbara, many of our listeners will be familiar with gray or blue or green hydrogen, but natural or white hydrogen is a new concept for most of us. So, what exactly is natural hydrogen? And can tell us a bit about how it's formed and maybe how it's different from other ways of producing hydrogen?
Thank you. That's always such a fun question to answer because it speaks to what are sometimes the solitudes in different research disciplines. You mentioned, and it's quite right, that this is something that's been known, particularly in the mining sector. Um, but you mentioned that those working in the hydrogen exploration sector somehow were slow to know about this, and that's absolutely true. I mean, even a couple of years ago, I heard someone say, we don't yet know if natural hydrogen exists in the subsurface of the planet or something like that. And that's a statement that would make every microbiologist on the planet fall off their chair because microbes do a lot of things in their metabolisms. But one of the key things that microbes do is use hydrogen. And so, in fact, what's fascinating is that people who've been studying microbiology, people who've been studying subsurface microbiology, that is, microbiology that lives 100 meters or 3 kilometers deep below our feet, they've been studying hydrogen for 30 years because it's one of the key food stocks that drives the energy of microbiology. And so, if we turn away from the economic exploitation of hydrogen for energy, we find out that, in fact, microbes have been using hydrogen for energy for long on the whole lifetime of our planet. And so there is information that's there. There's a quantity of information, but it's mostly been produced both by microbiologists and also by people studying for the exploration of Mars, for instance, where there's similar thoughts that something like hydrogen could have sustained life in the past.
Omid, let's bring you into that conversation. So, are there particular regions or geological conditions that tend to produce or be associated with natural hydrogen?
Yes, this question brings us to see how hydrogen technically naturally produced. There are two major processes that generate hydrogen. One, it's water radiolysis, which means in crystalline rock you have naturally occurring radioactive elements like uranium, thorium, and potassium. And with a long half-life, those the radioactive elements, and through decay of those elements, several particles emitted from that decay. One of them is gamma ray that can, with a high energy, can dissociate water in the pore spaces in the rock, and through the beta decay, another the alpha decay, another particle that emitted from those the elements, you produce helium. Therefore, with this process, you have both hydrogen and helium, which is helium is a critical element. And right now, with the current condition in the Middle East, we have a high technical need for the resource of helium. Another process for production of hydrogen is serpentinization, or simply hydration. And how it forms in the essence, when you have a high iron rich rock like ultramafic rocks or ophiolites in geologic term, when through water rock interaction, water reacts with ferrous iron, it's oxidized iron to iron 3, and the water technically reduced and produced hydrogen. With this introduction, with Canada, with a large landmass and type of the rocks that we have, almost everywhere in Canada, because almost 80% of Canada formed by very old rocks that everybody actually heard about, the Canadian Shield, a stable craton that have those crystalline rock and those iron-rich rock that can be a potential source of hydrogen. As a petroleum geologist, I'll always make an analogy with the petroleum system. For natural hydrogen, you need to have a source rock that produce hydrogen. You also need a migration pathway to lead your produced gas to a reservoir, and eventually a cap rock that seal the hydrogen in place. Therefore, with this respect, Canada has a huge potential, not only because of the type of the rocks, also because of the age of the rocks that we have. Canadian Shield is billion years old, and one of the key factors for hydrogen and helium production is time. Because the process of production is very slow, the rate of process is very slow, and therefore the older rock, the higher chance of hydrogen production. But we come to the fun question, how much is preserved? As Barbara mentioned, microbes love hydrogen, and the preservation and trapment right now is a major question for us.
Okay, so knowing there is natural hydrogen underground then leads for me to two other questions. How do we actually find it? And then once we find it, how would we extract it at commercial scale?
Yeah, I guess I'll jump in on that one. Oh, okay.
Go ahead, Barbara.
Uh, well, one key thing to mention, and this is particularly important for Canadians, is that setting aside for a moment your question about economic hydrogen, uh, we've already found hydrogen. Canada has an incredible natural asset in that these microbiological studies that I've mentioned have been taking place right here. And so I believe it's safe to say that Canada has more hard quantitative data to show that hydrogen exists than any other country out there. So then the question becomes, similar to what Omid was laying out, okay, if it's there and we know it's there and we know where it's there, uh, is there enough to be of an economic viability? And there it really comes down to how you scale that economy.
Okay, so you mentioned that, Canada has a lot of the geology that you would expect or that's associated with natural hydrogen, but Canada is a really big country. So knowing that there is natural hydrogen underground in Canada, how do you actually find out where in Canada it would be? And so if you're going to start exploring for it, like where do you actually put a stake in the ground and start looking?
Yes, as you know, for any exploration, you need some kind of proxies or leads for your exploration. For example, back in the oil exploration age, people actually looked at the oil seepage, gas seepage, and the superficial exposure of those products. This is the case for hydrogen as well. But we were lucky in Canada that taking it through research that Barbara started from her PhD thesis and the Canadian Shield, we already knew that we have some indication of sometimes high volume of hydrogen. For example, 50% in the deep mines in the Canadian Shield. But our question was where else in Canada we have those resources. Therefore, the geoscientists, we look at the oil industry because there is some the technical analogies between natural hydrogen and oil industry, and we have immense amount of the gas composition data from oil industry that by law they have to report to the regulator in the different provinces. Therefore, from the beginning, I started to talk and consult with Barbara to how we can use those data. Therefore, as part of our activity, we compiled all the gas data from academia, from the industry, from the government, and compiled in a huge gas database for Canada to find out where in those the gas composition analysis we see some anomalous amount of hydrogen as helium as well. As I mentioned, through radiolysis we produce the helium as well. Helium, like hydrogen, is not a reactive gas, is not actually loved by microbe. Therefore, it can be preserved in the system more than hydrogen, but it can be used as a proxy for hydrogen exploration. Another step is that actually we already discussed about the source rock. Therefore, geology is the first step to find out, okay, where those source rock are located. This is what we are doing right now at GSC with technically help of Barbara and her team to identify the major source rock in Canada, as well as the traps and reservoir, which is our major sedimentary basin. Therefore, first step for exploration that we started, or any other company to technically start, these are the historical the anomalies of hydrogen. For example, if I want to give you an example from Australia, back in 1930s, the people in the exploration for gas drilled some holes that they come up with 80% hydrogen. And this is the area that exactly gold hydrogen in Australia went back and drilled some holes and they find the hydrogen is there. Another example from US back in 1987 in Kansas, the natural gas well reported hydrogen, and they realized yes, there is a serpentinization or hydration process in that area. That's why Hytera went there, and in Canada as well, as I mentioned, the huge amount of work that Barbara has done on crystalline shield. We know that the evidence is there. The only thing that you have to actually piece together all of those pieces of puzzle and find the best areas to go for to have all of those components of natural hydrogen system.
Interesting. Barbara, is there anything you'd like to add?
Yeah, just to sort of put a ribbon on that to help encapsulate what Omid just said. There's essentially two models that are most applicable to Canada. One is what you might call a petroleum model, and that relies on the fact that the sedimentary basins of our country, which have typically been where we've produced oil and gas, there's a point where they, of course, come into contact with the crystalline rock, the Canadian Shield rock that's underneath. And way back in the 1980s, in my own research in Ontario, in the oil and gas wells there, we discovered that there is, in fact, an enhanced concentrations of helium right at that point of contact between the crystalline rock below, that's the source rock producing that helium, and the sedimentary basins above that accumulate that helium. And so that's one model. It's sort of a petroleum model where we might expect to find helium and perhaps hydrogen deep in the sedimentary basins and to drill it much like we drill a petroleum, oil, and gas approach. The second approach, and it's the one that we very much highlighted in the report that we did for the Royal Society briefing for the United Kingdom government on this topic, is a really important one for Canada because it focuses on the question of scale. Most of the hydrogen exploration that's been going on, particularly that's being done in that petroleum model, has the idea that the hydrogen that's going to be produced is going to be fed immediately into a global network of transportation of hydrogen around the world. And there's nothing wrong with that model. But one of the things we raised in the UK report was to point out that there's another model, there's a different model. And that's because the same kind of rocks that produce hydrogen on the Canadian Shield are the rocks we are already mining, whether that's for gold or base minerals or critical minerals. These are the same rocks that produce hydrogen. So when people think about the Canadian Shield, they tend to think about, oh, it must be remote, it must be far off. But as we point out, in some of these mining sectors, we may either have large cities or smaller communities, Timmins, Sudbury, Yellowknife, or we may have a co-location of mines. There may be a dozen mines in the same location. And we know these are places where there's hydrogen. And so it raises a second opportunity for Canada that I think is particularly important. We should explore the extent to which, in addition to any thoughts of long-term transport, we also take a look at this idea that we might want to use the hydrogen to supplement the local grid right there where that hydrogen's occurring, either in cities and municipalities or in industries that are co-located right on that rock. And that's an angle to this that I think has been very much under-examined to date. But it's one that, as a proud Canadian, I would really hope that we can begin to think about within the context of multiple scales of use of this resource.
So if we've known for a while that hydrogen exists naturally underground, globally, and in Canada, and if we even know what parts of Canada have the most potential for natural hydrogen exploration and extraction, why is it only getting serious attention now?
I'll just give a one-sentence answer because then I want to turn it over to you for the more in-depth one. The one-sentence answer I'm going to use is just solitudes, Derek. We've got microbiologists and planetary scientists who've been looking at hydrogen. We've got the mining sector who knows it's there. But then we have the new green energy business sector. And those three have just not communicated as effectively to this point in time. And so one of the things that we're trying to do in a podcast such as this, and the reason we so appreciate today, is that opportunity to open up those lines of communication so that we can put all that information together and figure out a path forward. And Omid, you're going to have a lot more important things to say on this, so I'm going to pass it right over to you.
Thank you so much, Barbara. Yeah, Derek, if you look at the history of hydrogen, hydrogen for a long time introduced as a good source of energy, and as you mentioned in your introduction, that the technical byproduct of the hydrogen fuel would be the water, and it's the relatively clean energy. But as Barb mentioned, again, we have other the low-hanging fruit resources for energy. We always actually went to them. If you look at, for example, the history, you see back in 1970s that we have again the hydrocarbon crisis, again unrest in the Middle East. A lot of people actually moved toward using hydrogen. We have one issue with hydrogen. It's highly technically flammable, and you cannot actually condense it to use it efficiently and economically. But technology advanced, and we have ways to use that hydrogen more efficiently and manage that the engineering problem, fuel cells, and so on. Another factor is that all the countries had set a net zero target. That one of the aspects is that actually to bring down this CO2 emission. And if I want to actually put in perspective, right now, globally, 100 million tons of the hydrogen used every year. It's a very large market, but unfortunately, most of that hydrogen come from the transformation of natural gas or coal resources to hydrogen that has a very high footprint. And right now, unfortunately, 99% of that come from gray hydrogen. technically break down methane molecules. It's a very energy intensive the process, and also one of the byproducts is CO2. Currently, we use hydrogen in fuel refining, in the ammonia, making fertilizer for agriculture, and 5% in steel production.
Interesting. Let's move on from the science and talk a little bit about the regulatory challenges, because I hear often that regulatory gaps and exploration hurdles are often mentioned as significant challenges for natural hydrogen. In many cases, the regulations around natural hydrogen exploration or extraction don't even exist. So, Barbara, where do you think Canada stands on sort of building the policy and regulatory framework that we're going to need to develop natural hydrogen here?
Well, I'm afraid it's exactly sort of in the same context that you placed it, Derek. Because this is, in terms of going after natural hydrogen for economic interests, because that's new. It's not captured in most of our drilling legislation, regulation, and monitoring. And that step will need to be taken to provide the sort of firm foundation that investors and business people look for to understand and build out their business models. So filling that gap is important. It's important all around the world. A couple of countries have moved quite quickly, but again, referring to the UK report, it was one of the key recommendations we made in that report that progress would need to be made both there and here in Canada. And Omid, I'm sure, has additional details on that.
Derek, we are working with federal government, and the regulation is not under our mandate. But we are working very closely to our provincial colleagues to see how their progress actually is made. For example, for the British Columbia, they added natural hydrogen to their gas regulation, and there is no the hurdle over there. In Saskatchewan, they technically use same as a helium exploration. That's why you see, for example, Max Power went there uh, for two reasons: one, regulation, and another one, we have a lot of helium over there, helium exploration over there. Again, going after the helium to find hydrogen. And Quebec recently working on updating their regulation. To be honest, all of the provinces are not at the same space, and they have their own regulatory problem. But this is the major technical hurdle for the international investor to come to Canada as a first opportunity to do that. And we are closely working with our provincial partner to help them with those regulations, but this is their area to act on.
Yes, similarly in Nova Scotia, they have a Mineral Resources Act that regulates mineral rights and a Petroleum Resources Act that governed onshore oil and gas exploration and production. But neither one of these acts explicitly regulated natural hydrogen. So the province recently replaced the Petroleum Resources Act with the new Subsurface Energy Resource Extraction Act, which has a broader scope, including creating a regulatory framework for the exploration and extraction of natural hydrogen. Um, this has been a really interesting discussion, and I want to close maybe with a look into the future. So I have a question for both of you. And it's a question about sort of natural hydrogen. So what I want to know is, what's one question about natural hydrogen that you want to try to answer with your research over the next few years? And if the science delivers, what do you think natural hydrogen realistically could mean for Canada's energy future? Maybe I'll start with you, Barbara.
Well, I think that's a very important question. And one of the key ones, I think, is again a question of scale, but a slightly different one. So far, a lot of the attention has sort of been focused on finding the one hit, the one well with 90% hydrogen. Having studied this phenomenon for 30, 40 years all over the world, I have to put forward that the data would say that's unrealistic. And that what we might want to be looking at is a more diversified portfolio where you might be looking at multiple wells producing smaller amounts of hydrogen. rather than the single one that's the high roller, as it were. That would be, I think, a welcome shift in the attention and the focus that gets put on exploration goals. But there's still many questions around that to be determined, because really, in the end, what matters is not the absolute concentration, but the long-term viability of what's found. Does the flow endure? Is there enough volume to be of economic use, whether that's on a grand scale or a local scale? The question remains the same. It's less concentration than volume and longevity of the reservoir. And so, the key thing that I would say in general, too, is to beware of anybody who is selling almost anything as a silver bullet. The energy crisis, and combined with the climate crisis that's been created on our planet, is such that we're going to need every solution out there. We're going to need to concentrate, to invest, to bring our best minds forward to a whole portfolio of options, including new resources, but also energy efficiency. And so, yeah, natural hydrogen, I happen to believe, can play a role in that, particularly for, as I've said, some of our co-located industry hubs and perhaps remoter communities in which the importation of diesel fuel, for instance, to a city like Yellowknife is very, very high. And Yellowknife is sitting on these hydrogen producing rocks. So I think these are all important angles for us to pursue, but I'm very careful of anyone selling a silver bullet.
Okay. And me, what's one question about natural hydrogen that you're hoping to answer?
As the federal the research agency, our mandate is to provide publicly available information, basic information for industry, for policymakers and academia, to where technically they have better chance of finding hydrogen. Therefore, our team, or very small team at Geological Survey of Canada right now, trying to put out the Canada-wide maps of potential source rock and potential reservoir and traps within Canada. And in detail states that Barbara mentioned again, that there's two schools of thought about natural hydrogen: one petroleum leaning and another one technically mining the orientation. Therefore, we are trying actually to make more clear the pathway toward those exploration. And one of the activities that, as a scientific question that we have, for the largest technically sedimentary basin in Canada and second largest sedimentary basin in the world, we don't know yet what is the composition of the Pericambrian shield, the lithology, the rock composition, and the lithogeochemistry. Therefore, our research is to refine those basic data for public and also industry and policymakers to better able to set the place of natural hydrogen in Canadian economy.
Well, thank you both. I know we really just scratched the surface of this really fascinating topic, but I really appreciate you coming on the pod today to share your thoughts. And if you enjoyed this conversation, please subscribe to Atlantic Canada's Hydrogen Future wherever you get your podcasts. Would love to hear your thoughts. You can connect with us on LinkedIn, or you can learn more about our work on our website at atlantichydrogen.ca. And thanks for listening.